So I have a presentation that I'm going to make. We then have a couple of Petrarca presentations, and then a half-hour discussion, and then another hour and a half of discussion. So hopefully, if we can get out of our high blood sugar, low oxygen level, we can engage in some discussion, debate about what we've been hearing over the past day and a half. I thought I would start with an anecdote. IMéRA is in the process of being integrated into the new university here. We will become what is called a university foundation next year. Right now we're a non-profit actually, and we're squatting on this property. We have no legal right to be here. About 3 weeks ago, Pierre Livet, who was here a minute ago, and I had a meeting with the university president to try and convince the university president that IMéRA was a good thing and that he should help us create this university foundation. And as I was going into the meeting, we were with the university vice president, who's a chemist. He said, "Roger, please don't talk to the university president about the earth science program at IMéRA. He's a doctor. The university has no money. They only want to work on important things." So I thought I'd just tell that anecdote because, as you know, part of the discussion and the framing for the StudioLabs consortium is really to look at maybe a meta level at what's happening. And Samuel, as a sociologist, likes to just make this simple statement that there are new social practices emerging between artists and scientists. And we have, over the last day and a half, heard some examples of different kinds of art and science collaboration. And so one of the things that the StudioLab Consortium is trying to do is to understand these different modes of collaboration, how you make them possible, how you make them visible, what are the roadblocks that make it difficult for people, like not having your name on the office door. As Patrice told us, the artist in residence here has her name on the door in the office. So the artist is not anonymous. The second thing that the StudioLabs Consortium is going to be discussing, and this workshop is part of that strategy, is how we develop new ways of engaging with different kinds of people around these kinds of questions. And so what I've put together is some of my material that I give in different forms that maybe can set a little bit of a background for the discussion after this session and for the final panel. Some of my colleagues have seen some of this material before, and I apologize. So, as I mentioned, last week I was in Chicago at a conference, and 3 scientists in their talk happened to mention that they were working on problems that matter. And so, just like Victoria explained to you how this location was created because of a problem that mattered in Marseille in the 19th century, where cholera was killing hundreds of people, and clean drinking water was just not available. And so they created these canals all over the region that brought water into Marseille so that people didn't die of cholera. And in fact, this grand building here is kind of a testimony to the problem solved. As I mentioned, in the climate change models that are now circulating, if you look at water availability in the Mediterranean region in the 2050s, that's 30 years from now, the red region will have up to 50% less available water because of lower rainfall, high temperatures, and so on. And so if there is a problem that matters here in Marseille, and both on the south bank and the north bank of the Mediterranean, is water availability. The easy way to deal with the problem would be to have 10 times fewer people. And in fact, in the past, that's what happened. In the American Southwest, when water ran out, the people moved. Human migration in the past has often been driven by climatic change. I don't think the people around the Mediterranean this time will have time to move, because 30 years is no time at all to start moving millions of people, and it normally happens in times of war, earthquakes, and natural disasters. This is a slow disaster, and so people will probably not move as the water supply is reduced. So here's a problem that matters, and I think that's part of the purpose of this kind of a workshop, is to refocus our attention on the complexity of these problems, all the way from weirdness in the water. I have to talk to you later, Victoria. You're too Californian in your ideas. And they have water shortages there too. And so there are two ways to look at water. And we have had here in the room several water scientists. And of course, I'm an astrophysicist, we have a mental model of the tree of knowledge with disciplines and subdisciplines. Don't read the fine, I found a tree, it's not a tree of disciplines. But indeed, in the 19th century conception of how knowledge is organized, you had this idea of déclination par disciplines and specialization, and that's been a very amazingly successful strategy, of course, in many fields of science. But the water problem is clearly a different kind of problem. Yes, you have to understand the water molecule and its different states and its behaviors, but you also have to understand the social problems, the economic problems, the transportation problems. And so somehow, when you deal with a problem that matters like this one, you have to toggle between the disciplinary view and the interdisciplinary view. And both approaches are needed in order to maybe solve the problem that matters. So this is easy to say, but I'm in a university where the physics department is on one campus and the astronomy department on a different campus, because the astronomers are left wing and the physicists are right wing, and so they're in different campuses. I exaggerate only a little. And so organizations tend to be organized that way, but the natural world tends to be organized that way. And so it's not so easy to mediate between these different strategies that are needed at different times. And let me tell you, if you're a nuclear scientist, you're much better in that disciplinary way of thinking. But if you're a water scientist, you're necessarily embedded in a more complicated situation. I want to introduce some terminology that's circulating in the United States at the moment. It's the STEM to STEAM movement, and it's a reflection of this discussion. For those of you that are not familiar, STEM is science, technology, engineering, and mathematics. As you probably know, in what are called knowledge economies, we need lots of trained scientists and engineers. And so governments put money into STEM education to train workforces in science and technology. In the last 2 years, there's been a viral movement of converting STEM to STEAM by introducing the arts, design, and humanities into the discussion of STEM education. And let me tell you, when you're a 16-year-old kid, and I had 16-year-olds, the worst thing you tell them is, young man, go into chemistry. Plastics are the future. Clearly, a 16-year-old doesn't think that way. The 16-year-old thinks that way because they've not yet been exposed to that way of organizing knowledge. And so there's a very interesting international discussion at the moment of how to integrate the arts, design, and humanities into the STEM disciplines. And we've had examples of this over the last day and a half. I would recommend to you the web video site by Roger Malina, who's a very well-known designer, is now the president of the Rhode Island School of Design. It's called stemtosteam.org. He got the URL quickly. And it's a series of videos basically articulating some of the arguments about how, when you're dealing with the kind of problems we face today, you've got to redesign not just culture, not just technology, I'm sorry, but you've got to redesign culture. And as we heard a couple of times today, Anna was talking about design approaches to problem solving, where the goal is to fail again, fail better, until maybe you've come to an approach. So I would encourage you to look at that website just to see some of that international discussion. So clearly, one of the problems that matters today is what's called the hockey stick graph. Don't read the numbers. There are now thousands of these graphs circulating on the internet, which showed that within the last 150 years, human activity has become such an important natural process that it's leaving physical traces in the fossil record, in the oceans, in the corals. We're now in what's called the Anthropocene era, because human activity as a natural process is now leaving physical traces. And so 100 million years from now, when people come and do archaeology here and geology, they will see a rupture somewhere around 1850, 1900, where human activity became so important as a natural process that it left physical traces. Now, of course, if this is population, it's one thing. If it's global warming, it's another thing. But clearly, we're in a very new situation, which is why I think the argument is we have to think about redesigning culture. So how do we solve problems that matter? When I was a student at MIT, it was a wonderfully simple diagram. I was a physicist. I started doing basic research in physics, and around me there were people who'd invented semiconductors, and so they did applied research. They filed patents. Companies were founded and people were employed. So there was this wonderful sort of utopian view of how science contributed to employment and the new society and the solutions of the future. And in fact, this occasionally works, this model. It's not going to work on the water problem, because the water problem looks more like that. And how you innovate on a massive scale, which is why I asked the question earlier of how you take small symbolic acts and have them be cumulatively transformative, is a real question. And so, unfortunately, if you're a physicist, you can often work like this. If you're a water scientist, you're usually working like that. Gerald Barnett, who's an innovation theorist, and he's done a lot of writing on what he calls third-generation innovation theory, and he talks about a number of things that need to be put into that picture. One is the cultural imaginary, which is what future do we think is desirable, and that is not a given. Over the centuries, the cultural imaginary has changed. People have very different conceptions of the future society that they would like to live in. We are still living with the ideal, for instance, of a nuclear family with mother and father and children, and we know that 30% of children in France have one parent in the home. So somehow, in the cultural imaginary, the nuclear family is still what we're talking about, but the reality is that single parent families are very, very common. Cultural innovation, it's no accident that Facebook has both innovated culturally and socially. It's now, in 6 or 7 years, one of the biggest capitalized companies on the planet. Very unusual situation. The founder of Facebook never finished his university diploma, as you know. Philanthropy 2.0. It now turns out that the biggest R&D budgets in computer science are not coming from where you think they're coming from the computer game industry. Suddenly, we find new sources of funding feeding into research and development that did not exist 20 years ago. And finally, innovation is happening in the strangest places. The Fab Labs, the hacker, the maker communities doing things, and in fact, Dimitri's presentation, I don't, you know, if you had been funded to do that, it would have been a 10 million euro European Union project, and you would have been told it couldn't be done, and so you would have been turned down, but you got it done anyway. So your sonoluminescence project. So, as we talk about the different modes of art-science collaboration, there are different kinds of arguments that I think we need to use. One is the creativity argument, and there's a creativity industry out there, and we had such a wonderful example of that yesterday when Patrice and Xaviera started talking about their aha moment, where suddenly both of them ended up having created something that hadn't worked 80 times before. Suddenly it worked, and they both said, yes, this is what we want to do, for very different reasons. And indeed, the history of ideas is full of those kinds of examples where people doing science or different kinds of creative activity get their ideas and their energy and enthusiasm through unlikely creative friction. Innovation arguments. Delprat showed us this afternoon a very sophisticated technological development. I don't know, Nathalie, whether you have filed any patents yet, but clearly in this art science work that she's doing, they're inventing things. And clearly those kinds of projects occasionally end up in things that are useful for other purposes and other people. Cultural embedding and appropriation. And I'm a little bit sorry that Monsieur Mou had to leave, but what he did is something really stupid. He took something that had already been done once, why do it again? And he put it into a different context, appropriated it culturally. It was a scientific experiment of seeding of clouds, nothing original there at all. But that act of cultural appropriation then focuses your attention on the problem in a very, very different kind of way. And so that displacement activity that comes through art science collaboration shifts people's attention and their focus. And finally, I want to talk a little bit, hopefully I'll have time, about the ethics problem. And I'm glad that Pierre is back. He's the president of the University Ethics Committee. Scientists don't like to talk about values in general. Science is pure, it's rigorous, undebatable, but in fact, science conflicts with so many human values that we really need to talk about the values problem. And so one of the things that happens in the art and science discussion is indeed people like Victoria start talking about weird science that no respectable scientist would ever talk about. And so suddenly we talk about the social context of heretics in science, and there's a very long history of heretics in science. And so the ethics of curiosity really comes back to the thing that human beings doing science are embodied creatures, they're cognitive. Curiosity is enacted, an experiment is a performance. It's cultural, it's determined by the interactions with the values of the society around you. It's social. In doing your science, you interact with other people, and it's collective. Almost all science today is done by groups of at least 2, sometimes several hundred people. So one of the things I've talked about a lot in the past is what I call intimate science, which sort of is a discussion that's come to me as an astronomer, because I realized, and Alain Azur, who's another cosmologist in the room, almost everything we know about the universe today comes from forms of energy that our bodies cannot see. And that is a very destabilizing thing. Boone talked about it in that quote, I think, a little bit. And so I think one of the problems is that when you talk about water, we know what it tastes like, we know what it feels like, but you don't have a clue what's going on within a mile of here, because you don't have a sense organ that tells you what the water density is within a mile. The way I like to introduce this topic is the first time global warming was discussed in the scientific literature was by Arrhenius, a Swedish scientist, in 1896. Actually, there was another paper in the 1850s where the heat trapping properties of water vapor were first, CO2 rather, were first detected. Of course, in the 1960s, Keeling started measuring the CO2 level in Hawaii, and it was unfundable. He happened to be the director of the observatory, I think, and so he did it on his own time. By now, we know that the CO2 level is rising. It took 100 years from that scientific result to reach the brain of the President of the United States. And maybe still hasn't, because I think in Rio they agreed to nothing. So this result is still not understood in Rio today. And of course the problem is that we think the human senses are wonderful, but they all block almost all the forms of energy that are coming on your body. And Dimitri just talked about cosmic rays. My body is flooded with cosmic rays right now. I just cannot detect them. They go right through me. They very, very rarely interact with my body. Depending on the energy, they might interact with a nucleus in one of the atoms, and there might be a genetic mutation triggered by some chain of events. But in general, we don't sense most of the things going on in our environment. That's true with CO2, which doesn't taste, smell, and it's true with so many of the other things that we need to know about. And so indeed the sensors, and don't read the fine print here, the black oval there is the part of the world that our senses give us access to. But there's all kinds of other stuff going on that our senses are just totally blind to. And so one of the fundamental problems, I think, when you're dealing with many of these problems that matter is that you're dealing with a reality that we have no direct sensory experience with. And so if you look at how our curiosity takes us in this diagram, as an astronomer, I study things that are big and happen slowly, up to the right of that diagram. If I'm a nuclear physicist, I want small things that happen quickly down on the left. Unfortunately, neither one of those directions is the right direction for sustainable development. And so we don't know where in that diagram we need our curiosity to go to change our culture, but it's certainly not in those two directions. And so one of the interesting things that seemed to me that scientists and artists do together is really make this kind of non-sensory data sensible, sensual. Intimate is the word I use. Of course, if you use intimate science on Google, you just get sex sites, so don't try that. I always like to use this example, although it's not related to water, by Catherine Mallory-Rocky, who's a young artist working with what I call smart textiles. She has a handbag with an NO sensor, a pollution sensor in the bag. When the pollution level goes up, the bag goes red. Now, of course, you can't smell the pollution. If you listen to the radio this morning, there was a pollution alert in Marseille. The speed limit is being reduced on July 1st down to 90 kilometers an hour on all the local freeways because the pollution levels are so high in Marseille that it's triggered the European Union health warning levels. Well, we just think it's hot. The truth is, I won't tell you what you're breathing right now, but you can't smell it. You might feel a little bit dopier. If everybody had a t-shirt that turned red when the pollution went up, let me tell you, we might actually do something about it quicker than when people start dying. So as an artist, she basically has been making that information about pollution sensual in some way. Very different example, Luke Jerram, who has a very nice artistic installation called Tide. The gravity in this room is changing all the time. As the moon goes around the Earth, the gravity vector and the gravity strength in this room changes. Our body is oblivious to it. What he did is he built a small installation with a gravity sensor, and as the gravity goes up and down, the water inside the bowl goes up and down. It's an artificial tide, and so you can put it in your living room actually, and it will tell you where the moon is because you can then calculate from the height of the water the gravity vector. So there, another trivial example, we have no gravity sense. We know which way is up and down. That's about our level of resolution. Here an artist has converted variable gravity levels into something tactile and visible. A third example, Anik and I work with a group in Ireland on the Leonardo Lovely Weather Project. A collective of artists called Soft Day worked with marine biologists on what are called ocean dead zones. As you probably know, if you go off the coast of almost all land masses now, there are areas that are biological deserts where there is no organic activity of any kind for a number of reasons, agricultural runoff, metal pollution, and so on. And what they did is they took that data in someone's database and made it into a musical performance with the teenagers in the town, converting knowledge about dead zones into a sonata. And so let me tell you, those 16-year-olds have a very different idea of what's off the coast of their village. When I first came to Marseille, I read Petrarca and St. Augustine. It turns out, as you know, St. Augustine came from the south bank of the Mediterranean, not very far from here. Petrarca lived most of his life around here. And in fact, there's a famous, and it's not apocryphal, a real story of Petrarca walking up to Mont Ventoux, and it was for him a personal transformation. And indeed, he said his climb was merely an allegory of the aspiration towards a better life. And so somehow, our art-science collaborations have to result in an allegory of an aspiration towards a better life. And so clearly this was 1,000 years ago. A lot has happened since then. And so I think there's quite a deep implication about the kind of work that we're encouraging here. And so indeed, Paul Suzanne, who also lived here and was a landscape artist, there's now a new generation of artists that become climate artists, but we don't know what that means yet. Their works don't sell in any gallery because nobody will buy them, just like nobody bought the Impressionists either at the time. And so clearly there's a transformation of here what I've called mediated sensuality. Okay, with the time that's available to me, and I'm sorry that Emmanuel, who was here yesterday, left, because he kind of defended science as the one true source of knowledge. It was precise. I'm exaggerating. So he's not here, so I'm not allowed to exaggerate. He showed the supreme confidence that most scientists that I know share among themselves about the place of science in society. Nobody needs to justify science. It's clearly good. But as you know, if you go outside of universities, a lot of people are not so convinced anymore. So is science in trouble? I went back and read a very famous report called Science, the Endless Frontier, written in 1945 by Vannevar Bush, who was an advisor for Franklin Roosevelt right after the war. And I'm just going to read it out to you because it's unbelievable. New frontiers of the mind are before us, and if they are pioneered with the same vision, boldness, and drive with which we have waged this war, we can create a fuller and more fruitful employment and a fuller and more fruitful life. Only scientists believe that today. Politicians don't. Just go look at the Spanish science funding and the cuts it's taking at the moment. In 1945, there was a very basic optimism about the role of science in society, which in fact has slowly crumbled. Recently, I heard Alan Lesner, who's the president of the American Association for the Advancements of Science, and he said, the link between science and the rest of society is a little fragile these days. He had just come from the US Congress negotiating the budget cuts in the US government where science is no longer protected from the budget cuts. And so indeed, slowly, we see an erosion in the general consensus that existed after the Second World War about the role of science in society. Helga Novotny, who was until recently the president of the European Research Council, has articulated in a number of articles the need for what she calls socially robust science. Society is moving to a position, is increasingly able to communicate its wishes and desires and fears to science. And so, indeed, there is I think, a very fundamental reorganization of the place in science and society. And so this question of values is not a negligible question. It's one that's fundamental. Let's see. I'm going to overrun by 2 or 3 minutes. What shall I do with my remaining time? Oh, actually, I'll be fine. So one of the things I want to just mention that I think is a very interesting development is really the whole citizen science movement that's going on at the moment. Here there's an example which is called community remote sensing. Because of the proliferation of cell phones and other technologies that are widely available, people are beginning to collect data for their own purposes. And in fact, Hehe and the group that they showed the work on the pollution clouds yesterday are part of that kind of a movement. And there's a very interesting, I think, development where in the past, you rarely found an artist that was collecting scientific data. We had several examples over the last 2 days of scientists working with artists where the artists were taking data for their own purposes. And so in a very real sense, I think one of the things that's going on, and this is part of what makes science socially robust, is in fact the feeling by artists that they have a right to take data for their own purposes. This is an example from a group in Boulder, Colorado. It's an infrared camera flown from a kite. You can actually measure whose lawn is being overwatered in your neighborhood if you want. You just send up the kite with the infrared camera, and the red color reflects the amount of humidity in the different areas of that landscape. Not something you can see, but there is a new kind of landscape painting where the artist is able to take data for their own purposes, in this case, that illustrates the consumption of water in the different parts of that neighborhood. Last year, I was on the Buckminster Fuller jury, and we saw about 30 projects of participatory mapping. The one that we gave a prize to was in the Congo. It was people in the tropical forest who, with their cell phones, were photographing the trees being cut down by the logging companies, where of course the government and the companies said there was no logging going on. And so basically they were just mapping where they lived, taking pictures, uploading them with GPS reference points, and then the lawyers were using that data to do the lawsuits in court. So all kinds of people are taking data for their own purposes. I'm going to wrap up. Another nice example from the oil spill in the Gulf of Mexico, the BP oil spill, I think it was. Jeff Warren, who was an artist at the Media Lab at the time, rushed down to Louisiana, and with balloons, with webcams on them, they went along the coast, taking photographs of the coast. They have the best data of where the pollution occurred on the Louisiana coast. And as you know, there is now huge lawsuits where the oil company has promised to compensate the people living along this coast. It was an artist who actually went and took that data and gave it to the lawyers so they could prove where the pollution had occurred and when it had occurred along that coast. So I don't know if it's art or science, it's certainly a political statement by an artist. So indeed, this is my last slide, as we look at the region we live in, what the hell is going on here, and what do we need to do when in the 2050s, the region is going to be short of water. And so indeed, to the extent that art and science helps us inform of the sense of place where we are, understanding what's going on here, then I think there is a very direct connection between these issues and the problems that matter. I'll stop there. Thank you.